Okay, sir.
A very good afternoon to everyone. I feel immense pleasure to introduce our guest, Mrs. Ramisha Rani, who completed her MTech in Communication Engineering at VIT, Chennai. She has secured second topper of the VIT. She has almost 5 years of experience in the field of artificial intelligence. She has worked with various companies like Tata Consultancy Services, Infosys, IT Solutions, etc. She has focused much interest in the field of Python, machine learning, deep learning, natural language processing, and data science. Currently working as data scientist in AICL with 5 years of experience, which allowed her to know and to discuss with industry trends, market analysis, and research oriented opportunities. Now I request Mrs. Ramisha Rani to address the gathering. Please, ma'am.
Yeah, thank you, ma'am. Thank you for the introduction. Good afternoon, one and all. So it is audible. If it is audible, please type S in chat box.
Yes, ma'am, it's audible.
Okay. Thank you for the confirmation. So yesterday we discussed about the feature selection process, right? The feature selection and dimensionality reduction. So today we are going to see the recommendation system. So the most popular real-time application we can see anywhere. If you open our mobile phone, even the YouTube, right? You can see the recommended videos based on your search history, as well as in the Amazon Prime, right? The Netflix, in a shopping app like Flipkart, Amazon. So all the selling products are using the recommendation system. So how they are exactly recommending the products based on our preference. So how the machine learning system helped to recommend the preferred product, right? So we are going to see how they have achieved such type of recommendation system in today's session, right? So, as I said previously, that everything is a recommendation. So, nearly Netflix has released one statement like 75% of viewers is fully based on their recommendation system. Because if any one of them are keeping any product, like companies are like selling products, so obviously they have to showcase their products to the customer, so that only customer will know, okay, these are the products available in their store or in their market. So if they any need for that particular customer, they will buy that particular product. So the recommendation system plays the very important role in the selling area, right? So as I said, maximum even in our Google Play app, so in everywhere there is a recommendation system, right?
One student ಆಗಿದ್ದ
So there are several types of recommendation system. Like first one is the collaborative recommendation system. So under collaborative recommendation system, we have two types. One is user based. We can say otherwise it is a memory based system. Then another one is item based, right? The second topic is content based recommendation system. Then third one is popularity based recommendation system. So in this session, we are going to discuss about the collaborative, okay, the two types of user based and item based, as well as the content based recommendation system, theory as well as the hands on. So first I will start with the collaborative recommendation system. Under collaborative recommendation system, we'll start user based recommendation system, right? So from the name we can easily understand that we are going to take user based. So all the recommendation is going to be based on the user, not on the item, right? Then why they have kept the name like the collaborative? Because based on several collaboration, we are going to recommend the system to the customers. Okay, we'll see. First, we'll see overview about how it works. Then we'll go deeper into the each step how you can build your own recommendation system, right? So if it is user based, consider that we have one user. So consider you are using Netflix or Amazon Prime, or you may consider you are in a YouTube also, right? So whenever one customer logged into their particular website, okay, to the particular platform, automatically the algorithm will start processing in the backend. So automatically it starts searching for the similar user. Okay. So if you are logged into any platform, automatically it starts searching for the similar user. So how the system will know this is the similar user for this particular customer? These are the peoples are similar for this particular customer. So again, fully based on the past history, right? So for example, this person like carrot and pizza and burger. Okay, so based on this history, okay, based on this history, okay, they are assuming this is a similar person because this person also used carrot and pizza, but he haven't tried the burger. So automatically the recommendation system will start recommending this burger to this person, right? So this is an overview how the similar user is identified. So similar user is identified fully based on the previous history. What is the perfect match? Like that. Clear? So we are going to take the movie data set. Based on the movie data set, we are going to recommend the films to the particular user. Right? So now we'll go a little deeper into the system, how it works, right? So for that, first we have to take the data set. So this is the data set, okay? This is the data set which consists of nearly 1 lakh rows and 4 columns. Clear? So it consists of user ID, movie ID, rating, and the timestamp. Clear? So user ID is going to be many. Like even if it is user ID, if it is for me, if it is user ID is 198, then I have seen many films. Then again user ID 8, for movie ID 9, for movie ID 11, I may have given some rating over there, right? So user ID may have many repetitive numbers, repetitive count, and a movie ID also that will be repeated. Okay, then ratings. For user ID 196, for the movie 242, how much rating that particular person has given. So these are the information is necessary to make the predictions, right? So this is a raw data set. What we are going to do is we are going to get the unique number of users and unique number of movie ID. How many unique users and how many unique movie ID, right? So based on that, nearly we have 942 user ID. Clear? Unique users in that particular data set is 942 and unique movie ID is nearly 1682. Okay, so I hope you're all aware about what is pivot table. So based on this pivot table, for unique value, we have converted the data set into this format based on the ratings. So how you can interpret this particular table? So for the user 1 have watched the movie ID 1 and gave the rating is like 5.0. Right? The same movie ID user 1 have watched the movie 2, the rating is 3. Watched movie 3 and rating is 4. But you haven't watched 1673rd movie. Like 1673rd movie you haven't watched by the user ID 1. Clear? So we are using 0 over there. Right? So if you want to check for the user 939, nearly he haven't watched so many movies, but he have watched the movie ID 9 and gave the rating 5.0. So again, this is fully based on the past data set. So based on the past data set, we have made some complete details about which user liked which movie and what ratings they have given, right? So the next procedure is we have to, based on this pivot table, we have to calculate the similarity table. So what is the purpose of similarity? How we can make similarity table? Right? So this is user-based recommendation system. So this is user-based recommendation system. So what we are going to do is, we are going to, so let me take one page. Okay. So consider, okay, consider that nearly we have 942 unique user ID, right? And we are using, working for user-based recommendation system. So our full concentration is all about the user thing, right? So nearly we have 942 users. So what we are going to do is we are going to make this matrix table, like simple table like 1, 2, 3, 4 up to 942, right? Same in this way, right? 1, 2, 3, 4, 5 and 942. Clear? So this is also, this index is also all about user ID, right? Users. And this column is also users. So how to interpret this data, this table? So the user, what is the similarity coefficient for user into user one? What is the similarity for user with the second user? What is the similarity of first user with third user? What is the similarity for first user with the fourth user? So we have to test with all the combinations, so that only we can effectively recommend the particular product to the particular person, right? So I told we are going to calculate the similarity for each users. So if you take the user third, and what is the similarity for user third with the first user? What is the similarity coefficient for user third with the second user? So there are two possible way of similarity. You can calculate similarity in two possible way. One is correlation, right? The another one is correlation. Clear? The another one is cosine similarity. Cosine similarity. So based on these two things, you can create any one of the similarity table, right? So here I have used the cosine similarity. So how cosine similarity works? So I hope you all know about what is correlation. So if x-axis increases, then y-axis also increases if it is positive. If it is decreases, then output variable also will get decreases. Right? We have several formula to calculate the correlation. How each variable is correlated. So the cosine similarity. So cosine similarity, it works with the angle. Right? For example, this is the plot for user 1. And this is the plot for user 2. And this is the plot for user 3. I'm going to make angle from the origin. Clear? So now tell me for user 1, which user is similar? For user 1, which user is similar? So for distance between, angle between user 1 and user 3 is, for example, 30. For same from user 1 to user 2, that is 60. So the similar user, the closest user for user 1 is user 3. So based on the shortest angle, we can say for user 1, user 3 is the similar user. So likewise, this is a concept, it applicable for even for lakhs and lakhs of data, lakhs and lakhs of users, right? So everything is simply coded up in Python in one line, but you have to know how it works. What is the exact principle behind each function, right? So in this way only, we have created the similarity table, right? So let me change the color, right? This is the for user 1, index has changed to 0, but anyhow, we can assume this is a user 1. And the similarity, what is the similarity for user 1? And what is the similarity of user 1? With 1, and you are checking with all the users. Clear? So now we have created a similarity, because first I told when you are logged into a particular platform, automatically the algorithm will start searching for the similar user. Consider your user ID is 938. Automatically it starts searching. It comes to this particular cosine similarity table and starts searching for which user is the closest similar user for this particular ID. Right? So for that purpose, we have completed how to create a cosine table. Right? So now the next process is the prediction process. So what is the prediction here? So before predicting, before recommending the products, we have one important process in recommendation system, that is the prediction table. So you can see here for the user 2 haven't watched the movie, okay, ID 2, movie ID 3, and nearly he have watched only the movie ID 1. So if you want to recommend the similar movie, we have to fill all this non-watched film by all the users with respect to the similar user. We have to fill all these zeros. So this is the crucial part in prediction in this recommendation system. So how we are going to fill this ratings exactly? So here the machine learning part comes into the play. Clear? So how we are going to fill this non-watched films by the respective user and movie with the correct sensible rating. So we cannot give randomly like 4, 5, 6, 7. So based on some logic, we have to fill this. So what if this person have watched this movie? How much rating he would have given for this particular movie? So in this perspective, we have to fill all the zeros. So we'll see how we can do that. Clear? So consider the three users, Joe, John, Al, and Nathan. So these four users have watched Star Wars, Who Brings, Contact, and Titanic. But the Nathan, haven't watched the Titanic. So based on the similar user concept, we have to take similar user based on their ratings. Based on their ratings, we have to do some calculation and we have to fill up this particular process, right? So we'll see how. So yesterday we have discussed about the scalar and vector, right? Yesterday we have discussed about the scalar and vector. So I hope you all are aware about what is vector. So in this vector format, we are taking all the values like 5, 2, 5. So only we are taking Star Wars, Hoop Dreams, and Contact. We are not taking the Titanic because that is going to be the calculating part. Right? So likewise, we are taking for Joe, John, Al, and Nathan. Clear? So we are taking the cosine similarity for northern because our area of interest is northern. For northern, we have to find titanium. So we are checking who is the best cosine similarity. Otherwise, we can check the cosine similarity index. So for cosine similarity of northern and Joe is 0.99. For northern with John is 0.64 and northern with Al is 0.91. Right? So based on this cosine similarity, we are going to calculate this particular value. We'll see how. Okay. So I hope up to this you are all clear. So what as our next step is we are going to multiply with the respective calculated cosine similarity, like 4 into 0.99 plus 3 into 0.64 plus 2 into 0.91. So finally we are getting answer as 3.0.3. So you can use any algorithm for this prediction table based on, you can try with the logical thinking. You can try with any kind of possible predictions, right? So 303. Clear? So likewise only we are going to fill all the columns, all the cells which was not given and watched by the respective users. Clear? So after the prediction process, we have filled all the values based on the respective calculation. So now you can see for 943 users, we have entirely filled with 1682 columns. Clear? So, okay. So we have did how to make the pivot table. We know how to make the cosine similarity. Okay. Then we know how to make the prediction table. Then what is the next step? So up to this, so what I have told up to this is the mandatory for, it should be pre-trained for every minute in our backend, right? This is going to be common for all the users. All the users, this is going to be common for all the users, right? Now the actual scenario comes into the play. So we have calculated all the needs to recommend the films to the particular user. So now we say the user is 34. So user 34 is logged into the system. So algorithm start finding the similar user. So based on the similarity table, the similarity score is 0.14. The shortest similarity score is the most similar user. So we have selected nearly 4 users. That is our wish to give 4 user, 5 user, 10 user likewise. Right? So the similar user 0.14, then the similar user, these are the similar users for the particular person taken from the similarity table, the cosine similarity table. Okay, what is the next step? Now we have the similarity users, right? So the next step is we are going to retry movies watched by those similar users, right? So user watched by, okay, movies watched by this particular similar user is movie ID 34, movie ID 45, 89, 673, 876 and 893, right? For this similar user, watched movies are this. So likewise, we have taken for all the similar user. Now we are going to take the same process for our input user, right? So now we have the movie list. What are the movies watched by the target? Okay, the target user, right? As well as the similar user. The next step is we are going to take only what are the films not watched by the target user from the similar user. So movie ID 34 watched by, okay, watched by the target user. 45 is also watched. 67 is also watched. 93 is also watched, right? Then 57. So 57 is not watched, right? So 89 is watched. 89 is watched. Okay. So 83. So 83 is also watched. 83 is also watched. So finally, we are going to take this from the similar user. So 673 is not watched by our target user. 876 is not watched by the target user. And 893 is not watched by our target user. Similarly, 56, 78 is not watched by our target user. Other 67 is watched. Then again 56 is not watched. 86, 90. So likewise, whatever the movies was not watched by the target user, we are going to make such movie alone in a list. Clear? Clear? So these are all the movie list is not watched by the target user, right? So now we have some list of not watched movies by the target user. So for example, just I have shown you nearly 1, 2, 3, 4, 5, 6, 7. But in the real time, that is going to be in a huge number. So we cannot recommend all those movies to the target number at a time. So we can do one thing based on the threshold value, we can only recommend based on that particular platform, we can recommend 5 movies to 10 movies, right? So how we can make the good recommendation? So already we have done some prediction table, right? We have calculated the prediction table. So this is the movie ID 34, sorry, target user ID 34. Go to the prediction table, right? Take the user ID 34 and check for the movie 40. What is the predicted rating? What is the predicted rating for 78? What is the predicted rate for 87? Because these are the movies not watched by the target user. So definitely all the values is going to be in a prediction form, right? So these are the prediction value. 0.99, 0.89, 0.75, 0.74. So based on this, okay, based on this value, we can make some threshold value. So just so finally, it recommending only the movie ID 50, 78, 87 and 90. Clear? So finally what we can do, we can go to the next movie ID title and put those name and retrieve the movie name alone, title alone. For example, the Interstellar, Inception, Gravity and Imitation Game. So these are the movies will be recommended for the target ID 34. So this is the principle. It works for parallelly. It works for all the users who have logged in, who are in the online to see that particular films. Clear? So here you can see one thing. We have used the user based because fully based on the user ID, target user ID, and we are selecting the similar user. Based on the similar user, we are retrieving the watched films. Based on that, we are segregating the non-watched film by the target user. Again, For those values, we are putting some prediction value. From that prediction value, we are keeping some threshold value. Based on that only, we are recommending 4 to 5 limbs. Clear? So the next one is, so these are the steps that I have followed to achieve this user-based recommendation system. Clear? So this is the final output. So this is the user ID 5, and I have passed the similarity table and prediction table, and I have set how many similar users I need and what is the threshold value. Finally, it recommending nearly 12 movies. These are the playable parameters. For same users, you can test with the playable parameter. Like you can go for 10 similar users and you can increase or decrease the threshold value. Right? So the second one is the under collaborative recommendation system, that is item-based recommendation system. So for any doubt in previous topic like user-based recommendation system, because that is going to be follow for the item-based recommendation system also. So here our full concentration is all about the item instead of user. Any doubt? Okay. No. Okay. So if we take item based, then we have to fully concentrate on the items. Like if you take a pizza, right, and burger, so automatically it starts searching for the similar items, right? And the exact reverse process of user-based recommendation system, right? So what we are going to see is which person has liked this pizza, which person has tried this pizza. And we are taking the similar item and we are checking which person is liked the burger, right? So how we can recommend? So these are the similar items. But pizza is tasted by one person and burger is tasted by another person. Because of this is a similar item, so that we can do one thing. We can recommend there is a high chances of liking pizza, okay, for the person who tasted the burger. And there is a high chances of liking, okay, burger for this person. So likewise, based on the similar items, we can recommend to the users, right? So again, we are going to take the same data set, but where the thing is get changes, again the same pivot table, right? But here we are going to make the similarity table for items, which means the movie IDs. So in previous case, okay, we did for 943 users into 943 users, right? But here for this item based, we are going to select for 1682 into 1682. Clear? Again, same cosine similarity. Clear? Again, you can use the same prediction table, how you can fill this movies. Okay, same prediction table. Okay, same process. So we have filled the prediction table. So up to this is going to be same. Now we are going to take the item. For the item 34, we are going to select a similar item, right? Donut, hot dog, and burger. And what we are going to do, we are going to take what are the users have tasted this particular item, similar items, right? So likewise, we are going to take for the unique user ID. So again, for this unique user ID, we have predicted value. So based on this predicted value, again, we are going to follow the threshold value. Clear? So finally, we are going to recommend for these uses. So for item that is pizza, we are going to recommend the pizza for these IDs. So we are seeing this example in the perspective of movie dataset so that you can consider the movie name like Interstellar. Okay, we are going to recommend this Interstellar movie for the movie user ID 50, 78, 87 and 90. Clear? So any doubt? Okay. So parallelly, we'll see the content-based the recommendation system. And these are the steps I used for item-based recommendation system. Clear? So the next one is content-based recommendation system. So how content-based recommendation system differs from the collaborative system? So far in collaborative system, we use the user item and based on the similar user of user item and similar item of products, right? But in content-based recommendation system, we are going to use only what are the content, what are the information present for each movies. So based on that, we are going to recommend the system to the users, right? So we'll see how the system works. So for example, consider first you will take the user like nickel and the vector for user is 906, which means what is the vector? So how many times he have watched? For example, we'll say we'll take animation film, okay, action film and thriller. So we'll understand the three categories. So this is the process applicable even for thousands of categories. So we'll try to understand with this three categories, right? So how much movies are watched by Nikhil, the genre of animation? So he haven't watched the action. So he don't like the thriller. So these are the vector that was created by the user for the Nikhil. So likewise, we have to create a vector for each film. Understand? We are going to create the vector for each film. So this is the vector like same for animation, action film and thriller. So this Toy Story is for action and thriller. Actually, this is for animation. So as of now, how we created the title, that is action and thriller. But Star Wars is animation. Both the concepts are 0. So these are the content information vector for each film. So what we are going to do with such vector? So we are going to do the calculation part for Nikhil, whether Nikhil is going to like the Toy Story or Star Wars based on his previous search history, right? So what we are going to do is 9 into 0 into 9, 1 into 1, 0 into 9, 1 into 0 and 1 into minus 1. So likewise, we are going to do sum of product. So finally, we are getting answer as -6. So this is the procedure same for item vectors 1, 0, 0. And we are going to multiply with this particular value. So finally, we are getting answer as 9. So for nickel, we can recommend, okay, he may like the star war because based on his content information and with the content information of star war, he is getting the value of 9 as a rating. So we can recommend the star war to the nickel. So here we have compared with only the 2 films. Think about we have to compare this with 1882 films. So this is the process. This is the process going to be same even for thousands and lakhs of movies, right? So to achieve the content-based recommendation system, we need only 3 important points. One is user vector for each user, clear, and movie vector for each movie. So we can create the content vector is equal to user vector multiplication of movie vector. Based on this content vector, for highest value, we can recommend the particular film to the user. Clear? So this is exactly how the movie vector is. Clear, we have movie for 1882 and content information for that movie is nearly 18 rows based on the movies category like action, adventure, animation, children's, comedy, crime, documentary, drama, fantasy, likewise. Like, so now we are ready with the movie vector. Now we have to go for user vector. Clear? So to create user vector, first step is we have to create the pivot table. So how many unique user and how many unique movie ID? Clear? So from the ratings table, okay, from the ratings table for the user ID 1, I'm going to take only movie ID and the ratings. So in this way, we can easily segregate the user on information alone. So based on the user information 1, we have created the single user vector. So this is the vector, okay, this is the 18 vector, okay, for the user 1. Clear? So the movie user ID 1 have watched nearly 271 films, and we have to check of each film, what is the vector for each film, so that only we can able to create the vector for each user ID. So final vector 18 vector, okay, final 18 vectors for single user. So likewise, we have to create for all the users, right? So how to create the user vector? This is step 2. Based on movie category, we have created the user vector. If you take user 1 and these are the vectors for 18 category values, calculated values, right? So finally, we have to do content vector. So how we can create content vector? The dot product of user vector and movie vector, right? So if you multiply what we have created previously, the movie vector and user vector and movie vector, you can easily get this 9682 rows into 943 columns. This is user columns, this is movie ID columns. Clear? So now, based on the threshold, we can recommend the movie for the user. So rating table, we need rating table, content vector, and for the user ID 45, we are going to recommend the threshold value for 0.3. So these are the movies will be recommended for the user 45. Okay, 45th user, we are going to recommend these films. This is going to be for content-based recommendation system. Clear? So these are the steps for content-based recommendation system. So we'll move to the coding part. So exactly what I have said so far, okay, what I have covered so far step by step, exactly I have coded in
Good afternoon.
Python.
Whether my voice is audible?
Yes, ma'am.
Darshini, are you there? Inform your friends to join soon. You alone joined. Nobody else inside. Me and you only there. And also inform your friends today is the last date for submitting their case studies. And also inform Bharati and Nandakumar to remove their case studies. And the case study remove பண்ணிட்டு நீட்டா வேர்ட் டாக்குமெண்ட்ல போட்டு பிடிஎஃப் கன்வெர்ட் பண்ணி போட சொல்லுங்கடா. அப்படியே நெட்ல இருந்து இன்சர்ட் பண்ணிருக்காங்க. நான் கொடுத்திருக்கிற கேஸ் ஸ்டடி ஏதாண்டா. கேஸ் ஸ்டடி இன்னும் முடிக்கல. 12 பேர் தான் சப்மிட் பண்ணிருக்காங்க. உங்க குரூப்ல போட்டுருங்க. டுடே இஸ் த லாஸ்ட் டேட். அதே மாதிரி பிருந்தாவையும் நந்தகுமாரியும் அவங்களோட கேஸ் ஸ்டடி போட்டதை ரிமூவ் பண்ணிட்டு ஃபர்ஸ்ட் அதை வேர்ட் டாக்குமெண்ட்ல போட்டு அதை பிடிஎஃபா மாத்த சொல்லுங்க. அப்படியே நெட்ல இருந்து டவுன்லோட் பண்ணி டைரக்டா இன்சர்ட் பண்ணிருக்காங்க. அதை இம்மீடியட்டா ரிமூவ் பண்ண சொல்லிடுங்க. புரிஞ்சுதுங்களா? ஓகேடா, தேங்க்யூடா. இன்ஃபார்ம் யுவர் ஃப்ரெண்ட்ஸ்டா. ஆல்ரெடி 3. We both only there. Nobody's there. பிருந்தா நந்தகுமார் ஏதாண்டா. ஓகே.
Shall I continue the lecture, ma'am?
You can continue, ma'am.
Okay.
Good afternoon. Let's wait others join. Only 2 have joined till now.
சார் எனக்கு கிராஸ் கனெக்ஷன் ஆகுது. மேம் இந்த லெக்சருக்கு பேசுறாங்களா வேற லெக்சருக்கு பேசுறாங்களா?
Ma'am, you can continue.
Okay, sir.
Ma'am, sharing option is there?
Sir, let me mute all the participants.
Yeah, yes, ma'am. You can continue, ma'am. No problem. I will do it.
Okay, sir. Okay. So we'll see how we can create the process recommendation system, right? So let me first restart this kernel. Okay. So first let me load the necessary libraries, like we are going to use pandas and numpy. Okay. So this is the data set we are going to, that rating data set. So let's see how this data set is looking like. So already what are the screenshot I have shown in PPT is taken from this, the output of this particular Jupyter notebook. Clear? So the next step is we have to know how many unique users and how many unique items. So let me run this. So nearly we have 943 unique users and a number of unique item is 1682. So using this inbuilt function from this pandas, the pivot
Inform
table.
your friends to join soon. Only 3 have joined till now.
So user ID, movie ID and ratings. So let me run this. So here you can see when I create the pivot table for all the users and movie ID, you can see the none values, which means these are the films not watched by the respective users. Clear? So data set, this is the movie lens data set 8K. It is available in the internet. You can take, otherwise I will provide the link where you can take this data set. Okay, the dataset name is movie lens 8K dataset. Yeah, sure, sir. I will provide the link at the last. Okay, so our purpose is what we have to do is we have to change this none value into 0 so that we can go for some calculation, because if it is none value or missing value like null value, the system cannot.
Inform your friends to join soon. Only 5 have joined till now.
So this is the data matrix. Okay, after the replacement of none value into a 0, right? So this is the using sklearn and metrics pairwise, we can able to input the pairwise distance. So in this we are going to give the metric as a cosine transform. So let me run this. So now we have created for user similarity as well as for the item similarity. Right? So we'll see how the user similarity is looking like. So this is in array. So later we can convert this into a data frame for easy use. So now we have created up to the similarity table, right? So the next process is we have to do the prediction. We have to fill
Good
all
afternoon.
this 0 into.
Let's wait others join. Only 7 have joined.
So we have to fill all the 0 values into reasonable prediction rate. Right? So here we are going to fill the prediction table for user as well as for the item. Right now we'll see how it looks for user. So again it is an array. So anyhow we have calculated the prediction part. So up to this is going to be the mandatory for all the users. Now, so now we have to work for the input user. Okay, the input user 34. So I'm going to create a similarity table. Okay, similarity table for user 34. So here I'm going to convert user similarity in, it is an array form, right? So I'm going to convert that into a data format. So what I'm going to do is I'm going to take the similar users of first 5. So let's see what are the similar user count, that is 34, 450, 852, 811 and 509. So we'll make this as a list, right? So the next process is using similar user input can select the movie ID from the rating table. So what is our next step? We have to take the movie ID for each similar user. So the length is 5. We'll see what are the list. Here you can see the movie list of all the 5 similar users. So we are going to make that into a single list. So using itertools function, we are going to make that into a single list. So now we'll see what is the length. Length is 663 movies are watched by the similar users, right? So we'll take
Only
one.
12 have joined till now. Inform your friends to join soon. Okay, we'll start. Let them join. So we'll see the continuation, whether my voice is audible to everyone. Reply in the chat box whether my voice is audible. Whether my voice is audible.
I'm audible,
Okay,
ma'am.
thank you. So today we'll see, thank you, we'll see the continuation of your laundry services. Last class we have stopped with the strains. So how we can remove our strains. So what are the procedures for removing those things? So in that first we will be having a
Can you
ball
mute
point. So
connection?
for that first we will rub it lightly, and it is with the, we will mix it with the cotton thing. So that strip will be there in your strain. Next is your blood. If it is a blood related thing, means first it will be soaked into your cold water for more than an hour. So and then we will transmit that to your normal thing. So that time we will put some detergents to clean all the infectious which are all present in that particular cloth. So we will soak it for 30 minutes. After that we will wash it properly. At that time the bacteria or viruses which are all present over in that particular cloth will be removed. Next, if the cloth is having
Can
a
you
chewing
mute
gum
the
means we
lecture?
need to remove that. For that removing, we will use knife for removing it, and we will apply some ices, and we will allow this to be there in your cold water.
Okay. Is it audible?
It's audible, ma'am. You can continue.
Okay, okay, sir. So for this, next we have to take what are the movies watched by our target variable. So let me run this. So these are the movies watched by the target customer. So we are going to take what are the movies can be recommended, like only movies which are not watched by the target user from the similar user. So this is the code snippet that will give you the process. Like recommended movies is nearly 570. So we'll start this one and we'll get the unique clear. So what we can do, one thing is we cannot able to showcase, we cannot able to recommend all the 750, right? 570, right? So what we can do, we can do one thing, like we can give some threshold value. Based on this threshold value, highest rated movies can be displayed. So I have converted all this array format, the prediction table, into a data format, and I have transported it so that we can easily get the values. Right? This is the code snippet exactly gives you for the threshold value. Clear? So these are the from 570 based on the highest rated movie, the value which is greater than 1. Okay, value which is greater than 1. We are recommending only 27 movie. So now we have list of the 27 movies. Okay, 27 movies. I'm going to use the item data set so that I can get the name of each movie, right? So instead of only displaying the numbers, that is good to display with the movie title, right? So these are the movie title. So I'm going to do some little bit neatness in the output instead of showing the array. So we have removed that into a list, right? So still we can make this as a one list. So finally, we are going to recommend this 27 film for that user 34, right? So this is for cross-check process. If we get empty list, then the logic is correct. Okay, so what I have worked for here so far, like line by line. So here I have checked the logic. It's working fine. So finally, I have converted all the process into, okay, all the process into a user-based. Clear? All the process into one single function so that I can run only by defining that function, only by calling that function. So let's run and see. And this is the recommended movie for 678 user, and we'll check for 67th user, and you can play with the values like here. This is for top 5 similar user, and this is the threshold value. And you can see the recommended movies also. So this is for user-based recommendation system. Exactly, I have developed the code similarly for item-based. Clear? So let me just walk through the process. So this is for item-based. Up to this is going to be same set of procedure. Okay, here just we have to change the variable name. So instead of user, we are going to calculate for item. So all the remaining steps follows remain same. So for this, everything is final answer is going to be user. This is the recommended user. But for user ID, that is going to be, okay, that is recommended movies for item. This is going to be the recommended user, right? So the data set for this is from movie lens 100K data set. So you can take from HitUp, Kaggle, and anywhere. Just type it, that is movie lens 100K dataset. So you cannot able to find such type of recommended movie process in internet. So this is I have created my own after uh, researching how the recommendation system actually works. Okay. So any doubts so far? So any doubts so far? So you can take this movie data set from Kaggle also. Right, in Kaggle movie lens 100K. Right, you can take and start working on this. So any doubt so far? So if you have any doubt, you can ask me. Otherwise, we will wind up the session. Yeah, I will share the program to the coordinator. So from them, you can get the codes hands-on for this session. So any other doubt? Shall we wind up the session, sir?
Yeah, yes, ma'am. One more faculty, where to get this data set? Please provide link. Already one faculty asked, ma'am.
Yes, sir. I have shown in the screen. From Kaggle, we can get this data set. So
Okay.
currently, I'm okay. Let me copy paste this link and put it in chat.
Okay. The same faculty, please share the program for understanding.
Yeah, sir. I will forward to you. Can you able to forward me? Otherwise, please contact me on this for in this WhatsApp number or to mail ID so that I can forward you. Okay, please note down this email ID and phone number. If you have any doubt regarding MLDL and natural language processing, you can ask me by contacting in WhatsApp or an email ID. Right? So you just mail me to this email ID. I will forward the code for those who are asking the hands-on. Is it clear, sir? Any other thing that I have to convey?
Yeah, yes, ma'am. No problem. We are going to wind up the session, ma'am.
Okay, okay, sir. Thank you, sir.
Okay, thank you. Thank you all. We are going to wind up the session.